Good evening. Welcome to this evening's webinar, Accessing Solutions with the TI-84Plus CE. We have a mountain of activities for you this evening. My name is Brian Lannon. I'm your host for this event. I've been teaching maths and physics for a fair while now, and I particularly enjoy the educational potential of using technology in my classes. Our presenters this evening, both seasoned campaigners, and both from Queensland. Ray Cross, a T-Cubed instructor, teaching for 40 years and using technology for half of that. Hello, Ray. Good evening. We'll get back to Ray. And our other presenter this evening, Jim Lowe. And Jim, from a fair bit of work with Queensland University and University of Technology, and also involved with QAMT and the Umi Deadly Mathematics Centre. Good evening, Jim. We will get back to them. Don't worry, they're there. So you don't want to be hearing too much from me. We will swap across to Ray.
Yeah, Brian, I think we've just got our microphones working here. Yeah.
That was muted. I think you swap over to Jim. I think now is the idea.
Sorry, Jim to kick us off.
Jim's going to kick off, yeah.
Okay, so sharing my screen now. Should be coming through in a moment. And there we go. So a little bit of a hiccup there, folks, but good evening and g'day, Brian. We're just a little bit, we were muted there after we swapped out of and went live. So we will get into it because we've got a fair bit of information to get through tonight. And that's the title for this one, Assessing Solutions with the TI-84Plus CE. And Ray and myself are going to have a look at a couple of different options and different ways that we can use this device. So I just thought we'd have a look at the overview of the session that was put out there and what hopefully enticed you to tune in tonight. So we said that we were going to use this 84Plus CE to develop, strengthen and assess students' learning of mathematics skills and concepts. And the red highlighting is there is mine. So I think it's, developing and deepening students' learning is the important thing, and then the assessment follows from that. And then using this device to provide feedback for the student, for them to assess their own learning, is what I'm going to look at tonight. And you can see a little image there on the side of the TI-84 with an image in there. So I'm going to start off tonight looking at how we can use images as, if you like, a context for some of this work on graphing and so on that provides feedback for the student. So I guess the first thing that we have to do is discuss how we get images into our TI-84Plus calculator. And as you can see on that slide, the CE can store up to 10 images, and you get them in there using the free TI Connect software, and the software actually does it all for you. There's nothing for you to do in the way of conversion or anything like that. And so I'm going to attempt to switch to one of the many things that I've got open, and I'm pressing the wrong keyboard again. Just bear with me, folks. Okay, let's go to TI Connect and have a look what we've got happening here. Now I've got my TI Connect software that you can see there. I've got it connected to my TI-84Plus CE calculator, and you can see what's going on there. It tells me there's only one calculator collected. I could have multiple ones there, which makes it easy to set up for a class, because if you can do this and transfer images to say half a dozen calculators hooked up to a USB port, then give them to the kids and let them transfer them to each other. A class can have all these images in a very short space of time if they're skilled in doing this. So what we do, we click on our Actions menu, and you can see that one of the options there is to add files from computer. So I'm going to click on that one and let that come up, and you see I did prepare this, so it knows exactly where I've been going to recently. But if it didn't, you would browse through your menu until you find the directory where you've got your images stored. And I'm going to take this particular image here, which a little bit hard to see in the thumbnail, but it's actually the convention centre in Cairns that I grabbed an image of it many years ago, and I lost it. And I was back in Cairns a couple of weeks ago, and I stood on the same street corner, but trees and so forth have grown in the way over the years since the first time I got it, but I got the best one I could anyway. Now, you can notice from that little pop-up there, if you can read it on my tiny screen here, that's 2.9, nearly basically 3 megabytes of image downloaded directly from a phone. But we just click on that, say open, and there should be a pop-up menu, and it will come up eventually. And you can see I've got some options that I could, if I had multiple calculators, I could send it to all the calculators or the selected calculators. I can replace existing content automatically, so I don't have to worry about that. And you notice that we said 10 images, it's going to name them image 1, 2, 3, 4, 5, and so on up through to image 9, and then image 0 to give us 10. Well, I'm going to put this one into image 9, and I'm simply going to send it. And as always, the little green bar's gone across there, and I could explore my calculator, and you will see all sorts of things on there. And somewhere down here, no, gone too far. No, well, I'm going to swap back to my emulator now where the image is already there. There it is. Background image, see them? 1, 2, 3, 4, 5, 6, 7, 8, and because I've just sent image 9, it's gone off on its own little spot there. Okay, so I'm going to swap back to the emulator so that you can see what's going on, because what I would do now, the image is now transferred to the calculator. I'm going to my format screen, so second and then the zoom key to bring up the format menu, and you would notice that at the moment my background image is off. Okay, so I'm going to arrow to that, and because I can scroll around, I just go up and around the bottom, and it's quicker to get there. And then I'm going to go sideways, and as soon as I go to image 1, it's going to pop up and show me what image that is. Now, even if you've never looked at this before, you do have half a dozen or so images already on your calculator, and I've left a couple of them on there. So these first few images are already provided on your calculator. So you've got a bridge with a bit of a curve there. We've got a playground, but you can see some obviously linear functions, parallel lines there. We've got an interesting bromeliad with some lots of parallel lines there. And then we get into some of my images, and you can see some parabolas, and we'll talk about that grubby hand there in a moment. And whoops, too far, letting away my secrets. There's image 9 that we had on there, and that's all we've got to do. Just scroll through. So that's saying image 9. We don't have to do anything else. If I go to the graph screen, then that image is loaded there. And we can then go and attempt to fit a curve to the roof of this building. Okay, so that's a very quick introduction as to how to get your images in there and how to use the format option, because as we said, if we simply scroll through there, we can change that image. I'm not going to, because I want to get on and look at this in a little bit of detail. Now, I'm going to go back to that graph, and I'm going to go to my draw menu and recall a graphical database, because I hopefully got this right, and enter that. And so what that should mean is that when I go to y equals, I've already got a sine function in there, and when I go back to my graph, you might notice that my axes have changed slightly to where I had them set up before. Okay, and I've got a default sine function in there, so that's our starting point, and we would be looking for students to modify this function and get it to fit that curve there. Now, it's not my purpose tonight to talk about how to, go through a sine function in detail. If you're teaching Maths B or the equivalent, you would know that. So I just want to talk quickly about the features of a calculator. So one of the first things I want to mention, you notice that even though the 84 is not a CAS calculator, I can work variables. So notice I've defined my sine function in terms of the parameters A, B, C, and D. Okay, and different people have different forms of that there, and so on, whatever you are working with. And we can go to the calculator screen, and you can see that I can assign values in there. And if I can probably scroll up a little bit very quickly, you can see that what I've actually done is put a value of 1 into the variable A, and 1 into B, and 0s into C and D, which in terms of my y equals, that's going to give me 1 sine of 1x and nothing else, so that's going to give me a basic sine curve. So that's how I get my starting function there. Now, a couple of little tricks or tips, if you like, if you want the kids to fit this manually. One of the things you can do, of course, is just bring up the trace point and maneuver that over to wherever you're looking to gather some data, and you've got your coordinates down there. But, we can be a little bit more efficient, because if I'm trying to get this, the x-coordinate here of the what should be the maximum of our function, by the time I get over here and then shift it up there and so on, it's a little bit time consuming. So you can actually speed it up if we go to the draw menu, and I'm just going to choose a vertical line. So now I've got a vertical line drawn through my cursor, so now I just need to zoom across here horizontally, and I just know this is going to happen in the webinar, that if I hold it down it'll move quicker, but if I just know if I hold it down too much in the webinar it's going to go straight over the other side of the screen. I'm going to save no time at all. But we will get there, and we got that there, and you can see that my x value is 3.56 and lots of decimal places and so on. And I can record that and then move my line over to somewhere around here and record that value, and likewise I can also, if I wish to, put in a horizontal line. Now, you might not think that that's terribly useful in this situation, but if you've got some experimental data and you've got a data set plotted there instead of an image, using this works really well, because if you've got a bit of variation in peak height, then using the vertical line gives you a sort of average height very, very quickly. If you can imagine 3 or 4 points up there. And I told you to go past it, and I hope I try to do it in a hurry. So to save time tonight, folks, I have moved a few things out, but I just thought I'd also point out that you see these values that are stored here. If we go back to our basic calculator screen, and I type in X and press enter, there's my value. So I can actually use that in calculation. So kids can actually use those values to help them calculate the amplitude and the period and so forth. So to save a little bit of time and not actually go through all those calculations, I've done a little bit of fudging tonight, and these figures are not perfect, but they're going to get us something that is reasonably close. And so let me have a look and see that I've worked out that the amplitude for this function is about 1.2 or a little bit more. So I can say 1.235 that we worked out here, and I'm going to store that in the variable A and do that. And this is the bit about the feedback, that if we change that, we're not going to see a lot with that one, but we should be starting to see that we've made that a little bit bigger, that we're now coming past the +1 and -1, and we've got an amplitude there that hopefully looks like it's about the same as what we've got on our building up there. Did some measurements with our vertical line and found out that we've got a period or a distance there between those 2 points of, let's say, which version am I going to use? Let's say 12.72. Now remember, that would be half a period in this one because we're going from a minimum to a maximum. So we'll double that and get something around 25. And so we can go back to our calculator and say 2 times pi divided by the period that I'm going to call 25. Which one am I using? 25.44. This might be too big, actually. I'm going to revise that down. I've got several sets of notes here. 22.8. Ooh. 22.80 will do us, and I can press enter and then get that value, and I'm going to again store that, so it'll pick up the answer, and I'm going to store that in the variable B, and that's done. And again, we can go back to the graph and have a look at what we've done to our curve now. And you can see that we've got something now that's approaching the shape of the roof, and we could continue that and move it up there and a little bit of a phase shift, and we could get that to line up quite reasonably. But I'm conscious of the time. I think you've got the idea of how you could use that with your students, and Essentially just using the calculator to provide the data set, to provide the points, and then let them work out the curve, and the calculator provides the verification. There's a couple of other things you can do. I'm going to look at a different application now, or a different example now, and change the image and look at this one first of all. And so we will graph this one, and I will just go into y equals and clear that sine function out of there and have a look at the graph. And for this one, I'm going to zoom to the standard window. And this is the thing about images. If you crop your image before you import it, then you could strike it. Like lucky, obviously this one just left a little bit extra in here, so you can see that that hexagon that's appearing there. And by the way, I should tell you where this hexagon's coming from, because this is a little, if you like, real life example. If you, I can, oops, wrong keyboard again. If I just jump into that one, if you go to Google Maps and search for Exmouth in Western Australia, that will bring you to the town of Exmouth that's down there somewhere. And then if you scroll up to the top of the peninsula, there's a big empty spot there, and you get this thing that's got this marvellous looking hexagon there, and it's actually an array of radio aerials. And so they're joined by these roads that's used to service them, which gives us this great little resource. It's actually, when you zoom in, tells us it's the whole communication centre. So you can...
Jim, if you zoom in too much, you might have ASIO knocking on your door.
Yes, well, let them try and find me, because there's so much junk in my study they'd be hard-pressed to find me, I tell you. So what I'm leading up to here is I'm just going to tweak this and change my window and make this to -11, and oops, I'm playing on -11 to 10 there, and just leave that there and go back to my graph. And that should now give me something that's pretty close to the centre. We could tweak it a little bit more, but for the purposes of tonight, that's good enough. And if anybody hasn't seen it before, we go to the Stat menu and take on the Calculations. Hidden way down the bottom of that menu, so I'm going to scroll up and go around the back way to get to it, is this quick plot and fit equation. So I'm going to hit enter to select that, and it'll take a little second to load the app, but now you can see I can drop points. And so I'm going to take the punt again that this can move fairly quickly when I hold it down. That's not too bad. And get over there and hit enter to drop the point. And then I'm going to keep coming down and maybe go a little bit further, and then across onto this line. Again, because it's obviously a straight line, it's linear, I don't need to go right down to the vertex here, but that's sort of close enough, and hit enter to drop that point. And now you'll notice that once I've got 2 points, it can possibly fit an equation. So we use the top row of keys, which become the function keys, and to fit an equation, going to hit that, and going to let me fit a linear equation. But you can see I could be using much more complicated sort of data there, and get that linear equation, and this is where we need a little bit of a song and dance act just to fill in this time while it works out that equation, and of course works from left to right, going across there and filling in the x points, and so eventually it will draw in my equation right at the end of that graph, and it will give me the equation. And I have the option of storing that equation, so I go to the function key there and store it, and come down there, and I'm happy to store all that, and say OK, and so that's stored in there. Now the thing about this one is that we can say to the kids, okay, you've got this equation here, and it's stored, and we can see what it is because we just stored it into y1. What would be the equation of this line over here? Okay, and so if we have a look in our y equation, we can take a little punt here and say that, well, let's assume that it would have the same gradient. So I'm going to approximate here because I need to give Ray some time, 2.7x, and I'm going to say, well, we've shifted it over the other side. The whole thing is symmetrical, so it might be a reasonable guess, if you like, to say that it's going to be 18.85 or 18.9, say, and let's go and graph that. And yeah, with my sort of rounding off there, that's still not too bad. And you can see that the image provides a stimulus for whatever activities we choose to come up with. It's not just, oh, let's find a graph, but let's find a graph and then see what else we can do with it. And that's the great thing about the images. So the other activity that I won't go into in detail, but just show you very quickly, because that was the actual theme of my whole part, that I called this presentation when I did it originally, Maths in the Palm of Your Hand, and that's why we had those images before. That this came about because, and I need to get back to this one, this was an activity with students, and obviously those equations don't mean too much anymore, and I'm just going to zoom back to the standard axes there and graph that. And so, yeah, it was an exercise in finding the equation of that line on the hand, and that came about one day. You know, when you're trying to engage kids in the classroom, we just had a computer hooked up with a little webcam, and we said, hey, let's capture an image. And we did that, and if we, whoops, probably still won't give me that now. Yes, went to the, oh no.
I think just looking at it, Jim, it means you're going to live a long and prosperous life.
Oh,
reading.
I should be so lucky. I should be so lucky. It's all yeah, all the things we do here on webinars, you know.
Yeah.
So you get the idea, but I just quickly, I mean, we've just graphed y equals 2x there, and you can see that, you know, kids could learn from that, okay, that looks pretty good in parallel, and we could add a y-intercept there. So let's go over here and say +5 and graph that, and we've got it. And so the whole idea of the activity, however, is that those other images that we've got there, if I quickly do this before handing over to Ray, and I've said that 3 times, so Ray's probably getting a bit edgy.
Do we know what the hand's up to? Yeah.
So if we do that, what we actually did, this is the same image, but we flipped it using some photo software. And so you can see there's the line which has effectively been reflected in the line in the y-axis, and so now we can pose to the kids, well, what's that equation going to be? And you can see as teachers that it will have the same y-intercept and it should have the negative gradient.
Negative,
so we can do that. And the other two images that I've got on there, we flipped it in the x-axis and then flipped it in the y-axis again, so we sort of went round and took the line all the way around the curve, and the kids were working out, well, what's got to change? Is it the y-intercept that will change, or is it the gradient that has to change? And they could play with it. And some people had more interesting hands and the lines actually curve a bit so that they can change the exercise there. But I think I've given you enough to see that there's a lot you can do with images to provide a source of an activity for students. And I will send this to Brian to put up on the website that I do have somewhere. I actually prepared a little Word document that sort of summarises everything I've said tonight, and so I'm talking about these images. And, you know, we've looked at two methods. There's other things you can do on this calculator, and there's a bit of discussion there about, you know, what your priorities are in the lesson and how you use it. So, Brian, I think I better stop there and let Ray have a go.
Okie doke. Yeah, thanks very much there, Jim. I particularly like the idea of the using, as you called it, the basic function, which you said with the trig curve, or the sine curve, and then you do the transformations on top of that. So yeah. It makes students think about, you know, as you said, phase shift, amplitude, period of a sine curve, and then of course on a simpler level, linear functions as well.
Yeah, and it just gives them that visual feedback. And, you know, the first time the kids do that and they actually follow it through and add in, you know, I did A and B, if you add in the values for C and D, and the curve just, especially if you leave D to last, and it just moves up there and lines up and everything lines up, and it's a bit of a wow factor moment when they actually see that and they get confirmation that they can work it out for themselves rather than just pressing a regression button all the time, you know? So I think it's really powerful.
Yep, certainly, agreed. And participants, can I remind you, if you do have questions of Jim, now he'll be handing over to Ray, and type them into either the question panel or the Q&A panel or into the chat panel. Could I ask you to direct things to all panellists? That way I'll see your questions, as also will Jim. Ray won't, because Ray's going to be busy sharing his gems of wisdom with us. So thank you, Ray.
Thanks, Brian. Just coming up now, sharing the screen. You see that now?
We do.
Okay, beautiful. Look, just following on from what Jim was saying before, basically a couple of weeks ago I did a webinar with Mel and from Queensland as well. We were looking at the TI-Inspire, and we used the little acronym Euler, little play on words, and basically that's exactly the sort of thing that Jim was saying and that I wanted to target, namely that by exploring these things, understanding, finding relationships, Jim finding them with images, as you just see here, and basically I'm going to look at data logging and data sets to establish relationships, and in particular we're going to look at linear inverse and trig functions and so on. But just like Jim was saying, the whole aim of the thing is to use the facilities that exist on the TI-84 to be able to encourage students to establish relationships and learn maths, and then use facilities to be able to assess their learning. So we're going to kick off by having a look at some data that I just picked up from the US site. That is apparently there are 11 hamburgers found from 3 different fast food stores, and they've been measured for fat and calories. So that's one for particularly people of my vintage to keep in mind. So you can see that this is a sample of our hamburgers here, and if I go to the TI, what I can do is I can load a data set just like Jim was doing before to make things a little bit easier. I've already done that. So in here we've got a graph, and this data here has on the horizontal axis it's got fat gram, and on the vertical axis it's got calories. So we can check that out just to save a little bit of time here. Plot 1, fat gram against calories. Plot 2 is off. We're going to go down there, and of course keep in mind we'll also look at inverse functions. If I turn that plot on and then graph it, what we get is that result there. Now obviously the red graph represents on the horizontal axis calories, and on the vertical axis fat. And if we were to put in this y3 equals x graph in the y editor, you can see hopefully that one of the plots is essentially a reflection of the other, and of course that's really what an inverse is all about. You can get the equation of each of these just by doing a little regression. So I'll just do one of those, go to Stat, Calc, and we want to do a linear regression, so that's number 4. And in that we've got fat grams and then calories, so it's already in there. So basically coming down here, we're going to store that to pressing bars and across to y bars, and then it's a function of course, and we've got y1, so put that in there and press enter again, and it calculates it. Hopefully it's working way up there. Always good to keep an eye on that, otherwise you tend to get a bit anxious about what's going on. So it's very good R squared value, and when we go into y editor then we can see that in y1 we have the equation. Now I've done the same thing with the data set reversed, and so to save doing that, because we now know how to do that, I'll just turn that function on, which is our linear regression function found in a similar way, and graph that. And you can see those two graphs plots pretty well go through the, should pretty well go through the data points, because the R squared value was quite good. Y equals x comes up. And you can ask a few interesting little questions. Here's some that I just thought of that students, I've done before, students find worthwhile discussing. What's the relationship with fat grams and calories? Well, rather than just talking about y equals mx plus c with m being the gradient, here of course if we go in here and look at our y editor, it's clear that this y value is calories and this the x value is grams, so the coefficient represents the number of calories per gram. So you've got around about 11.8 calories per gram, and of course the reciprocal down there, grams per calorie. Now another interesting question that I've found students like to investigate is can a hamburger have no fat? Well, again, using the facilities built into the TI-84, we can just do a little calculation, control calc, put a value in there of 0, press enter, and you can see that the blue graph is the number of calories per, or calories on the vertical or dependent axis against fat on the independent axis. So you can see that with no fat, it's still got calories. Right, interesting question which tends to provoke a bit of discussion, and clearly the answer would be that there's more than just fat-containing calories in a hamburger. There's obviously carbohydrate, protein, and so on and so forth. That's rather interesting, and it's using the graph to get some real-world information. I think that's the sort of thing that we should be doing. So there's a few other things that we can ask there. Can the hamburger have no calories? We could same thing, get a negative result. Of course, that's not possible. So let's just try something a little bit different. If you just type in to your browser world temperatures, you come up with some interesting sites, but one of them gives all the world cities, major cities. Then you can just click on the temperature scale over here, so it can convert from centigrade to Fahrenheit to Kelvin. And for those scientists and chemists and scientists doing that, it's worthwhile, rather than just learning fairly laboriously and slavishly a formula. We can find out what the relationship is from real world data. So what we've got to do there is just load in another graph database. So we'll come down there to number 4, and this one is loading in database 1. Now, if we look at what we get there, again, to save a bit of time, I won't go through the regressions, etc., because they're done the same way as we did it previously, the calories fat graphs. But the blue one represents the Fahrenheit scale on the vertical axis, with the centigrade scale on the horizontal, so centigrade to Fahrenheit, and vice versa for the red, and the black graph represents y equals x. So you can clearly see that one's a reflection of the other, and there's some interesting questions about that. Pretty obviously the first one is there a logical independent or dependent temperature? I know in Maths B in Queensland, and certainly I think maybe Jim might be able to tell me, I think in Maths A as well, we looked at what was independent and dependent variables, and obviously in the previous case I think it was obvious, the fat and calories, but in this one it depends on what you're doing, and so it's a bit debatable. It's not necessarily so that one or other of the three scales should go on the independent variable. So that's worthwhile discussing. How do units of degree centigrade and degree Fahrenheit compare? Well, looking at our Y editor, we can see that well, we can't actually, but anyway, yes we can. Sorry, just go back there. I was looking at the wrong function. If you come down here to Y6, when I've done the regression equation, the linear regression, I whacked it in, it's come out to be 1.81. Now we know, of course, the answer is 1.8, 9/5 centigrade plus 32, so it's 1.81 and it's got 31.7, but these figures have been rounded off. So we're looking at each unit of Fahrenheit corresponds to approximately 1.81 units of centigrade, and there's the inverse thing there. Now the other question is, what about this little intersection down there? What's that all about? And we can use the calculation button, and we look at number 5 to get an intersection, and certainly that's the first curve we're interested in. That's not the one we want the red one, which is that one. So I'll press enter, and I'll take a, I think I did that incorrectly. I'll do it again. Second calc, we'll look at number 5, intersect, and that's certainly the first curve. Now we want the second curve to be the red one. That's correct, so enter. And I'm going to take a rough guess here of -40 and see how good that is. And we'll enter that, and it's working way up there. and you can see in actual fact it's negative 38.9. We know the real value is negative 40, but who cares? We're using data here, and pretty clear with these two functions that we've got on, namely y6 and y7, if we put in that value that you just saw for y and for x, you get both sides of the equation being equal. So that's rather interesting. In terms of inverse functions, I find that over the years students have had a bit of difficulty doing that, and one of the things that you can do to help you with that sort of thing using the facilities of the TI is we'll just load in a different database here, I think, to start off with. So let's do database 2 this time. So recall 4, and we're going to come in with database 2. So that's done. So if we do sort of something pretty similar to what Jim was doing before, if we put the number 2 in and we stored that to n like that, then when we look at the Y editor, I've tried to save a little bit of time here and put a couple of interesting functions in. Not that interesting, but you've got for y4, you see you've got x to the n. So we've now got n stored as being 2. So I'm going to turn that on. And if we come down here, this is just getting kids to try and work out what the inverse is going to look like algebraically. So hopefully they come up with something like this. We turn that on, and then if we graph it, we might just have to come up here and just turn these others off for the moment. So we'll turn that one off. We'll come down here and turn the next one off. So we'll graph those two, and we should get a parabola and its inverse function. There's the parabola, and it should be coming up in a moment. The inverse function. Obviously we've got to put in the 2 bits because we can't plot a relation. Now what we can do, of course, and I guess you're probably running ahead of me with this, is that, and that's y equals x, is that you can pretty easily change the value. Just quit that. Quit. Okay, change the value of n. Let's put in, say, a 3 and store that to n. There we go. And then if we graph, it's going to give you both the positive and the negative inverse function, which is that one, and it'll give you the other one as well because the plus and minus one that we've got in front is a list. There we go. So that's rather interesting, having a look at those sorts of things. You can also draw an inverse, which is not something that we really wanted to emphasise, by just going to the home screen, and within the home screen you can access draw inverse from the draw menu, and we drop down there to number 8, draw inverse, and you can put in some graphs in a couple of ways. One of the ways is you can just put in the function that you want to have the inverse of. So maybe we just put in something like 2x minus 3, and it will just automatically draw the inverse of that. I think it comes up in blue from memory. That looks like the function.
Yeah, that's pretty cool, isn't it?
That's pretty. Actually that's the inverse. That's not the, because these units on the scale I think are single scale is
It's
minus.
looking, yep.
That's looking pretty good. Yeah.
Mm.
So do that. The other way in which you can draw an inverse, just try and save a bit of time here by not turning these functions off. But the other way in which you can do it is second draw, and hang on, we need to come back there, and we go down to number 8, and we can put in here one of the functions that we already have on in the Y editor. Now you can put in whatever you like. So basically, I don't know.
That you put it in as Y1, for example.
Yeah, well, I'm going to put in Y3. I'm going to put in the inverse sign because that's one that I want to concentrate on. So if we come back, Brian, to put in here, just go across and bars, Y bars function, and we'll use Y3, I think, because that's pretty interesting.
And of course we have to use the draw feature because it's not a function what you're coming up with, is it?
Well, that's right, and that's right. And the interesting thing is that when you use the draw feature, it graphs it as a relation, graphs the whole thing as a relation every time. It's actually not, doesn't seem to be coming for some reason or other, I don't know, but basically if you, we might just have to do this again, I think. We might just put in something.
Is that right? But of course you've got a restricted domain on that.
Yeah, I had a restricted domain on that one, but if we put in, say for instance for Y4, because that's already in there, maybe we just put in sign of X, that sort of stuff. It obviously graphs it with the axes rotated through 90 degrees and flipped. So it's rather interesting to sort of have a look at what happens with that. And the other sort of area that I always use with students, which I thought might be interesting to have a quick look at, and a bit mindful of time here, so we're going to keep moving quickly, is what I usually get before I start working on this is just to get kids to take a piece of paper and to see what we're doing here, and to cut a square out, and then they always seem to have problems with this idea of flipping the X and Y. So a square piece of paper, we can do this. Horizontal axis is usually the X-axis of the independent variable. Vertical axis is usually the Y-axis of the dependent variable. If the piece of paper is folded along the diagonal, that'll be the line Y equals X. Draw a function on the graph. Rotate around the line Y equals X. And then the X-axis is now being placed on the vertical, or what becomes the dependent axis. The Y-axis is now being placed on the horizontal or independent axis, and the inverse function is as shown. So that's just something that I found is pretty useful if you just get kids to be able to do that sort of stuff. The other one that's rather interesting is the Euler bank. Obviously, we all know that if you had an interest rate of just down here of 5% and it's compounding continuously, then the expression for that is e to the 0.05 times the number of years. So basically, you can flip this around and the inverse function is that there. There's a graph showing what's going on with respect to that. I just might move forward a little bit quickly. You can ask good questions about this one. How much money will I have after 5 years? When will I double money? What's the average rate of growth? And so on. I'll just show you a couple of things there. So it's in graph database 2. So we've already got that in there. So if we just flip up here, we're just going to turn that one off and just go up here to hopefully this one. We'll turn that on, drop down and turn the next function on and graph those. There's a couple of interesting things that I don't know that we use very much with the with these calculators. There's two graphs that you saw before, and of course the data plots match those regression equations, this one being an exponential and that one being a log regression equation. That's the other one we're not interested in at the moment. That's the slide. That's the drawing that we did before. Anyway, if we just ignore that one, and we should perhaps take those off. But basically, looking at the questions here that I thought might be interesting, you've got when will I double your money? How much money will I have after 5 years? Well, that's pretty easy. Just whack in the idea of x being equal to 5. When will you double your money? Well, basically all you need to do there is come down and put in a function, say 2. Let's drop it down a bit. Sometimes it's a bit slow. So let's clear that and put in 2 and then graph that. And then we just look at the intersection between those two and we can find out when it will have grown to be 2. So that'll come up fairly shortly, I would hope.
And the point of intersection, yep.
And just got the point of intersection there, so that's fine. But the other one, the other little question here that I found most interesting is what is the instantaneous rate of growth, those last two, after 10, 15, 20, 25 and 30 years, and how much does the instantaneous rate of growth relate to the amount at each year? Well, what you can do here, nice little trick, I thought anyway, is if you go to second calc and number 6, divide x, and if you insert, say, a value 10 and enter that, that tells you the rate of change, instantaneous rate of change is 0.0. Now what you can do then, if you go back here, that answer, I think Jim might have done this something similar before, that answer you can actually store into, say, one of these cells in a list. So if you went to list 3 and we put it in cell 1, you can store it in there. And then you can do the same thing with another instantaneous, and then you can look at the way the whole thing works. So I think you can probably understand where I'm going with that one. So just very quickly then, because we've pretty much run out of time, Brian, I think, but very quickly, the other interesting thing is to look at restricted domain and inverse trig functions, and basically you can see here what you would expect to get when you look at the inverse of a trig function, because it can't take the inverse of the value less than -1 or greater than +1, so you can get that sorts of graphs there. When you come down here though, and I'll put these in, where you're sort of taking sine, inverse sine of the sine and inverse sine of the inverse sine, it's interesting the sorts of results that you get, and it's all to do with the different quadrants in which it lies. So that's really, really worthwhile investigating. I'll have that sort of data set to you on the files that you receive with the information from this webinar. And there's good information there on Moonlight, which I won't go into. This is one to do setting up some data on the CBR, and then down here in Pendulum, which I did, which is rather good. I rather like this one. Gives you some great data. So if we go in here, I don't know whether people know how to use this sort of stuff, so I'll just quickly mention, go into the Easy Data app, and we haven't got that loaded at the moment, so there's nothing there. But if I go in File and I open a file, here are the three files I did for pendulums of 150, 125 and 175 centimetre. So we might just open the 125 one.
So it's with the motion detector plugged in?
Yeah, with the CBR plugged in, and I just swung a pendulum. It was just looking at the pendulum swinging in, and it gave me this data here. Right? Now, what's happened is back to the PowerPoint, that's the data that you just saw for 125. There's the data that if I had loaded the 150 file, it would have given me that. There's the data for the 175 file, and the questions you could ask, of course, they could test this whether the bob mass or initial pendulum angle affects the period. Of course, it doesn't, so it's interesting to get them to do that. How do you use the data to find the period versus the length and the inverse functions? Well, pretty clearly, if you look at your data here and you get a period, and you get a period here, and you can do that by going into the Easy Data app and just go across there, right, and tells you that that's a time of 0.25. Continue along here, and you can see that I think it comes up to be about 2 seconds, the period of this particular pendulum. You can get that. So you do a little subtraction of your 0.25 from 2.5 to 2.25 being the period there. Probably be better to do it between a couple of peaks and average. But if you do that for the 3 here, and you look at the length and you do a little regression between the two, you should be able to find, you know, t is equal to 2 pi root ln g and the inverse of it. For the physicists, very quickly, you can also, in the Easy Data app, you can also plot out velocity or acceleration. So this is the same one, the 125, where I superimposed on the red distance versus time graph, the blue velocity versus time, and the green acceleration term. So that's really great for the physics students to be able to analyse this sort of stuff and to find the relationship between the two. And then just finally, one thing that I would like to quickly remind anybody listening is that there is an upgrade of the operating system on the TI-84 CE coming through in the next couple of months in the States fall, so look for that. And if you keep checking the TI Australia site, there's tons and tons of material there, including any upgrades of operating systems. So I think that sort of pretty much means we're over time, Brian, so I'll hand back to you.
Terrific, and thank you, Ray. Yes, with the new operating systems and extra features coming in all the time, that fit equation one that Jim showed earlier, that certainly wasn't in the earlier generations of the TI-84s, but a great one to put in. And I think things that have been there for a while, but I don't, and Ray was using to great value, but I don't think they're as widely known. Things like the graphical database for saving your settings and your functions, and of course some of the other features that are found in that draw menu, where of course the function editor by definition it can only do functions and not relations, but if we do want to graph a relation, we need to use the draw menu for that. So thank you to both our presenters this evening, to Ray and to Jim. And just a reminder that when we check out, please fill in the feedback form and look for the follow-up files and support material for this webinar. And if you want to watch the whole thing again, you can either via our website, or a lot of the webinars are now being uploaded to the YouTube channel. And stay in touch with the whole lot by subscribing to the newsletter. So it's a good evening from me, and
good
Jim
evening from
and
us.
Ray.
And good evening from me. Thanks, Jim. Thanks, Brian.
All the very best. Cheers.
Thank you.